Let us go in detail with the problem. What they are asking: use a Regula-Falsi method to find a real root of the equation. So here is the equation, correct to 3 decimal places. So what we do, we take this LHS function as f of x. Let us start with this by taking it as f of x. Yes, we have taken that as f of x. Now what we do is we search for the values of a and b for which the function takes opposite sign, that is, one is negative and other is positive. Let us search such values of x. So as we have already explained, we have taken 0 for which it is negative. Similarly, next we take x is equal to 1, it is also negative. So we got again negative, so we need to continue this till we get positive. Next value we go for x is equal to 2, again we got negative. Next value will be 3. Yes, here we got positive for x is equal to 3 and negative for x is equal to 1 previous value. So we can conclude our root lies between 2 and 3, that is a is 2 and b is 3 we can take. So we conclude that a root lies between 2 comma 3. A root lies near to. Why we are saying this? Why the root lies near to this 2? Yes, we have already explained, because this minus 1 is very near to 0 than 16. 16 is not so near to 0 as when we compare with minus 1. So that's why we say root is very near to 2. Now let us take one more value which is very near to 2 and that lies between 2 and 3. Yes, we have taken 2.1 which is very near to 2 and lie between 2 comma 3, and we check what is the value of the function, whether it is negative or positive. We have put 2.1 in the places of x in the function, so we got 0.061 which is positive. So as I said, we got f of 2.1 as positive and f of 2 is negative. So new range we will get which is smaller than the earlier, because one is negative and another is positive. We can conclude that our root lies between 2 and 2.1. So this is the next conclusion. Now let us write now. So therefore what we have, f of 2 is less than 0. So this is what we have written here. And what the other thing just now we got, f of 2.1 is positive. So one is negative, another is positive. So we can conclude that our root lies between 2 and 2.1. So we are concluding that line here. Now we go for Regula-Falsi formula and find one more new root between 2 and 2.1. So what is the formula? In step 1 we find x1, first approximation we can call. So what is a here? A is 2, b is 2.1, f of b is f of 2.1 value, and f of a is f of 2 value, that is minus 1. We substitute all these values in this formula to get new x1. So these are a comma b and these are f of a and f of b, that is f of 2 and f of 2.1, which are required in the above said formula. See, all these values are required in this formula we have collected. If you substitute, it looks like this, and if you use the scientific calculator and simplify this, you will get this new root x1 as this. Now let us find what is f of x1, so that we can further reduce our range, so that we can further reduce our range. Let us find f of x1. So we find f of x1 and simplify this, which is less than 0, which we got as less than 0. So to maintain the opposite signs, since this is less than 0, among these two previous functional values, take the functional value which is opposite to this, opposite to this. So which is opposite to this? Since it is less than 0, what is the opposite one? Is greater than 0. So we can take greater than 0, which is opposite to this. So what is the new conclusion now? Our root lies between is 2.0942 and 2.1, because we got opposite signs in the functional values. Our root lies, we are just saying the sign of this is negative and sign of f of 2.1 is positive. So therefore our root lies between this value and this value. New range we got, that's what we have written here. Again we find one more new root by using second approximation. Let us use the second approximation in the second step. The formula remains the same, only change is here. In second approximation we take it as x2, a is here, b is here, and f of a, f of b we already noted down in the previous slide. Let us write down those values here. Substitute a, b, and f of a is this, f of b is this. Substitute the values of a, b, f of a, f of b in the formula. You will get this. Simplify this. You got one new root x2. So this is the one. Now you can conclude our answer, because the second approximation is same as the first approximation, almost same, because x2 and x1 are almost same. We can stop our process here and conclude thus the required approximate root correct to 3 decimal places is 2.095. We have corrected up to 3 decimal places. Since this is 5, we can neglect that 5 and make one increment to this and make it as 2.095. That is what we have noted down here. So this completes the problem by using the Regula-Falsi method.